Hello guys, I'm Sankalp and today we are going to learn about entity types, attributes, structural constraints, and weak entity in DBMS. So let's get started. These are the topics which we are going to cover in the video. As we all know that DBMS is an essential tool to manage data, but do you know how important entities are in DBMS? The role of entity is the representation of management of data. In this video, we are going to discuss entities in an entity is referred to an object or thing that exists in real world. For example, customer, carbon, etc. Entities are stored in database and they should be distinguishable. That is, they should be easily identifiable from the group. For example, a group of pens that are from the same company cannot be identified. So they are only objects. But pens with different colors become unique and they be called an entity like red, blue, green pens, etc. In a group of pens, we can easily identify any pen because of its different colors. So a pen of different colors is an entity. In basic terms, distinct and unique data is known as an entity. Let's take an example. A student, employee, bank account, etc. All of these are entities. As we can see in the table down here, employee is the entity name and ID is the primary key attribute. We are going to discuss about the attributes uh, in the further slides. Different types of entities. There are two kinds of entities which are as follows. Tangible entity. It is an entity in DBMS which is a physical object that we can touch or see. In simple words, an entity that has physical existence in real world is called tangible entity. For example, in a database, a table represents a tangible entity because it contains a physical object that we can see and touch in real world. It includes colleges, bank lockers, mobile cars, etc. Intangible entity. It is a non-physical object that we cannot touch or see. In simple words, an entity that does not have any physical existence in real world is known as intangible entity. For example, a bank account logically exists, but we cannot see or touch it. A collection of entities with general characteristics is known as entity type. For example, a database of a corporate company has entity types such as employees, department, etc. In DBMS, every entity type contains a set of attributes that explain the entity. The employee entity type can have attributes such as name, age, address, phone number, and salary. The department entity can have attributes such as name, number, and location in the department. Again, there are two kinds of entity types, which are as follows. Strong entity type. It is an entity that has its own existence and is independent. The entity relationship diagram represents a strong entity type with the help of a single rectangle. Below is the entity relationship diagram of the strong entity type. Uh, from this example, we can see customer is the entity type with attributes such as ID, name, gender, customer, and phone number. Customer is a strong entity type as it has a unique ID for each customer. So here ID works like a primary key. Weak entity type. It is an entity that does not have its own existence and relies on a strong entity for its existence. The ER diagram represents the weak entity type using double rectangles. Below is the ER diagram of the weak entity type. Address is a weak entity with attributes such as house number, city, location, and state. The relationship between a strong and a weak entity is known as an identifying relationship. Using a double diamond, the ER diagram represents a relationship between a strong entity and a weak entity type. As we can see, the strong entity type contains a primary key, but the address doesn't contain because it is dependent on this. So we can call it a weak entity. Entity set. An entity set is a group of entities of same entity type. For example, an entity set of students, an entity set of motorbikes, and an entity set of smartphones or customers, etc. Entity sets can be classified again in two types. A strong entity set. In DBMS, a strong entity set contains a primary key as I mentioned it earlier. For example, an entity of motorbikes with the attributes, the motorbike's registration number, its name, model, and its color. So we can see that is the table of the strong entity set where it has a unique registration number. The name can be same, even the model and the color, but the registration number is unique for each and every motorbike, so it is considered as a primary key. So it's a strong entity set. A weak entity set. In DBMS, a weak entity set does not contain a primary key. For example, an entity of smartphone with attributes phone's name, color, and RAM. As we can see in the representation below, the name of the phone may be similar. Like many of the phones have the same name, so it's not unique. So same goes with the color, RAM, and ROM also. So this would be considered as a weak entity, as it does not have any primary key. Attributes. In relational database, attributes are the characteristic properties that define all the items belonging to a specific category applied to every column cell. We can think of attributes as the values that are used to describe a specific member or attribute as a column in an entity table. There are 6 different types of attributes in DBMS, which are composite, single-valued, simple, multi-valued, key, and derived attributes. So let's discuss each one of them. Composite attribute. As the name suggests, those attributes composed of many other simple attributes are called composite attributes. Properties like student name can be further divided into subparts like first name, middle name, and last name, where each subpart can form an independent attribute. Similarly, address property can also be composed of state, city, country, etc. So below is an example of an ER diagram of a composite attribute. Simple attributes. Such attributes that cannot be further subdivided into several attributes is called simple attributes. For example, attributes like current, class, and branch of a student have an absolute value. They cannot be further subdivided into other parts. Like we divided full name into first name, middle name, and last name. Multi-value attributes. Those attributes which can have more than one entry or which contain more than one value are called multi-valued attributes. For example, attributes like phone number, email ID, and hobbies are categorized as multi-valued because a single student can have more than one phone number, email ID, and hobbies. Derived attributes. Such attributes whose value can be derived from other attributes of entity are called derived attributes. Values stored in derived attributes can be obtained from processing other attributes. For example, properties like age of a student can easily be obtained by subtracting the current date from the date of birth attribute for the student entity. So age is a derived attribute and it's represented by dotted lines. Complex attribute. Nesting multi-valued and composite attributes together form a complex attribute. Complex attributes are formed by arbitrary nesting the composite and multi-valued attributes. For example, a person owns more than one house and each house has more than one phone number. Then attribute form is represented as a complex attribute. So here in the example below, we can see that this is the attribute name, which is address phone, and it contains multiple phone numbers and email IDs. Similarly, address also has it's a composite attribute which is further divided as we discussed in the first example. A composite attribute is formed of many simple attributes. So address can be further divided into street, city, state attributes. So mixture of all the other attributes raised to an complex attribute. Finally, key attribute. Those attributes which can be identified uniquely in relation table are called key attributes. For example, a student has a unique attribute. Weak entity types. In relational database, a weak entity is an entity that does not have a primary key attribute of its own and is dependent on another entity called the owner or parent entity. Weak entities are identified by a combination of their attributes and primary key attributes of owning entity. There are 2 types of weak entities, total participation and partial participation. Total participation weak entity. A total participation weak entity is one that is existent that existence dependent on owning entity. This means that every instance of weak entity must be related to a specific instance by owning entity. Total participation is often denoted by double diamond in an entity relationship diagram. Example, consider a database for university. The entity course may be the owner entity, and a classroom could be the total participation of the weak entity. Each classroom is uniquely identified with the combination partial participation weak entity. Partial participation weak entity is one that can exist without being related to the owning entity. It does not require a relationship with the owner entity for its existence. Partial participation is often denoted by a single diamond in an entity relationship diagram. Example, continuing with the university database example, consider textbook as an partial participation weak entity related to the course entity. Each textbook is identified by its ISBN, but it is associated with the course only if it is prescribed for that course. Structural constraints. Structural constraints in the context of databases refer to rules or conditions that dictate the structure of the data model. These constraints help ensure the integrity, consistency, and correctness of the database by defining limitations on how data can be restored and related. There are several types of constraints, including primary key, foreign key, unique, check, and default constraints. Let us discuss. Primary key constraint. A primary key constraint ensures that a specific attribute or combination of attributes uniquely identifies each record in a table. Example, in the student table, the student ID is a primary key, guaranteeing that each student has a unique identifier. Foreign key constraint. A foreign key constraint establishes a link between two tables by ensuring that the values in one table referencing column matches the value in other table. Example, in the employee table, the department ID is a foreign key referencing the department ID in the department table. Unique constraint. A unique constraint ensures that all values in a particular column or a combination of columns are unique within a table. Example, in the email list table, the email column has a unique constraint ensuring that each email address is unique. Check constraint. A check constraint enforces a condition that must be true for each record in a table. Example, in the product table, check a constraint on the price column might ensure that the price is always greater than or equal to 0. Finally, default constraint. A default constraint specifies a default value for a column when no explicit value is provided during an insert operation. In the customer table, the name column might have default constraint to provide a default name if none is provided. Uh, Thank you guys.